So we're going to look at problems from chapter 5. And so let's take a quick look at some of these problems. Problem number 1 says your bank is offering you an account that pays and 20% interest rate. This 20% interest rate is for a total of 2 years. What will be the equivalent discount rate for different time periods? So if we look at the formula on page 129, 5.1, equivalent end period discount rate. Equivalent discount rate is 1 plus the 1 year discount rate over n periods minus 1. So over here we have R is 20%, that's our R. So we can put this 1 plus 0.2, and I'm going to raise it to the power n. N is going to be 6 months relative to 2 years. So in this situation, n is 6 over 24. 6 over 24 is 1 quarter minus 1. So that would be 1.2 raised to the power 1/4 minus 1. And that will give us 1.0466 minus 1, or 0.0466, or 4.66%. And similarly, you can do this for 1 year. If this was 1 year, what would happen? We would change n. We would change n for 1 year. For 1 year, n is going to be 12 over 24. And for 1 month, n is going to be 1 over 24. And we can calculate the equivalent interest rate, the equivalent discount rate. Question number 2. You are looking to buy a car. You have been offered a loan with an APR, annual percentage rate of 6%. And this is compounded monthly. What is your true monthly interest rate? So again, if you check back on your textbook, your formula is 1 plus EAR is 1 plus APR. So we know the formula. 1 plus equivalent annual rate is 1 plus the annual percentage rate over m raised to the power m. Okay. So over here, we are looking at compounded monthly, so that's our m factor. APR is already given as 6%, so this is 1 plus 0.06, m is 12, raised to the power m. Raised to the power m meaning m is going to be 12. So that gives us 1.0617. Thus, equivalent annual rate will be 1.0617 minus 1, or 6.17%. So although the nominal rate is stated as 6% annually, because of monthly compounding, your effective interest rate is 6.17% annually. Effectively, you're paying a little bit higher than what the annual percentage rate is. The true monthly rate, of course, interest is 6% divided by 12, which will be 0.5%. Okay, so that's problem number 2. Let's look at problem number 4. Which do you prefer? A bank account that pays 5% per year, equivalent annual rate for 3 years, or an account that pays 2.5% every 6 months for 3 years. So essentially you have to compare what would a $1 deposit into a bank account that pays 5% interest, what will you have in 3 years? So you can put this on a timeline. So if you put a deposit of $1 today, and that $1 was paying you 5% interest per year, what will be the future value in 3 years? So future value in 3 years would be present value times 1 plus r to the power 3. Present value is 1, this is the $1 deposit that you made, times 1 plus r, which is 0.055%, over 3 years. So if you do this, if you do the math, after 3 years you would have $1.1.1763. So this $1 would grow to 1.15763 in 3 years. The alternative same 3-year time period, but payments are being made every 6 months. Interest rate is being compounded every 6 months. And that interest rate that is being compounded is 2.5%. So this is half a year, 1, 1.5, 2, 2.5, and 3. Same $1 deposit. What will be the future value? What will be the future value in year 3? So you could do this using your financial calculator. Your present value, -1. Interest per year, or interest per period in this case, 2.5%. And number of periods. Number of periods over here, notice, is 1, 2, 3, 4, 5, and 6. There are 6 periods, 6-month periods. So n is 6 over here, and you would compute future value. If you do that, it's 1.15969. 1.15969. So again, semi-annual compounding yields a higher future value than annual compounding. And similarly, you could have done this one, part B, an account that pays 7.5% every 18 months. So that means your interest timeline is like this, is 3 years, but interest is being paid every 1.5 years. And the interest rate over that 1.5 year is 7.5. So again, you could do this. Your present value will remain as 1. Your interest would now change from 2.5 to 7.5, And the number of periods, essentially, there are 1, 2 periods. So there are 2 periods over here. You will compute future value, and that comes out to 1.5563. So that would be 1.5563. So notice that if you compound more frequently, your future value goes up. When you compound less frequently, when you 1.15563. When you compound less frequently, your future value goes down. Okay, so you get a little bit of an understanding of the relationship of compounding to how much you would have at a future time period. All right, so let's take a look at problem number 9. Problem number 9 states that this is a payday loan, significant moral hazard over here in the structuring of payday loans. And when we work this out, you will see what I mean by that. The payday loan would say you will pay a $30 fee for a 2-week, $200 payday loan. That means when you repay the loan after 2 weeks, you will pay $230. So this $30 fee is effectively an interest. On what? $30 of interest on $200 of capital. $30 of interest over $200 of capital. You can do the math. $30 of interest over $200 of capital makes this effectively a 15% interest rate over a 2-week period. What will be the effective annual rate? The effective annual interest rate would be 1 plus 0.15. Okay, so it's 2 weeks over a year. How many periods would that translate to? There are 26 periods. So 2 weeks over 52 weeks gives us, 52-week year, 2-week time period gives us 26 periods. So 1 plus 0.15 raised to the power 26, and then we would, of course, subtract 1 from it. This would be 1.37 1.378568 minus 1. So this is 0.378568, which implies it is not 1 point, I made a mistake. Let me redo the math over here. No, so this would be actually 37.6. 37.8568 minus 1. So that is 36.8568, which implies it's a 3,685% effective annual rate. So a $30 fee over a 2-week period for a $200 loan is equivalent to paying an annual interest of 3,685%. That's what I mean by moral hazard. This is not regular borrowing and lending. This is a form of social exploitation. But that's another subject for another day. But you can see why, when people draw attention to the moral hazards of payday loan, what they're drawing attention to. All right, question number 14. You have taken out a car loan of 20,000, so that's your principal, with a 6% APR. This is being compounded monthly, and the loan is for 5 years. When you make your first payment, how much of the payment will go towards principal and how much will go towards interest? So the first thing we have to calculate is what is our payment? What is the monthly payment? So essentially, you have $20,000 car loan. So your present value is minus 20,000. Again, minus just for the calculator convention. Your interest per year, per period, is 6%. That is, interest per year is 6%. Interest per period would be 6% divided by 12. 6% divided by 12 will be 0.5. Why am I dividing 6% by 12? Because it is being compounded monthly. 6% is my annual rate, so my monthly rate is 0.5%. And how many periods do I have? This is a 5-year loan, but monthly compounding, so I multiply that by 12. That makes n equal 60. Okay. And now when I compute payment, that payment comes out to $386.66. Now, that's my monthly payment. How much of this will go towards interest? Well, interest payment in year for month 1 will be based on the 20,000 principal multiplied by the 0.5% multiplied by the 0.5% monthly interest rate that you are paying. So 0.5% monthly interest rate would be 0.005. Okay, so that would be equal to $100. So that means from this 386, $100 is interest, and the remaining 286.66 represents the principal repayment. Now, when you go forward into the next month, what happens? Your principal would be reduced by 286.66 from the original principal of 20,000. And so 0.5% on that would be lower than $100, which means as you proceed through the loan, you are paying less and less in interest and more of the principal. But upfront, you pay more of the interest and less of the principal. Question number 30. Question number 30 is about inflation and effective real interest rates. So the problem states that inflation rate is 5%. So that's inflation, I. What is the nominal interest rate necessary for you to earn a 3% real interest rate? So the formula that we have is that 1 plus the real interest rate, and to designate this as the real, we need to make a quick note. that this is the real interest rate, so this is RR. Not just R, we designate nominal interest as R and real interest rate as R subscript R, times 1 plus the inflation rate will equal 1 plus the nominal interest rate. So we have to solve for the nominal interest rate. What will be the nominal interest rate necessary if your real interest rate is, if you want to earn a real interest rate of 3% and inflation is 5%, then that product is going to be 1.0815. That will be equal to R. So nominal interest rate, just to make it explicit, I'm going to put nom over here to indicate that's the nominal interest rate, is going to be 0.0815 or 8.15%. Now, speaking of this in an approximate sense, that real interest rate plus inflation is approximately equal to the nominal interest rate. So had I done this, it would have been 3 plus 5 would have given me 8. But the actual number is 8.15. So if inflation is very low, then we can get away with this approximation. But to calculate it in more exact sense, we have to use the product formula to calculate nominal interest rate. Okay, so that completes the tutorial for chapter 5.